Hey everyone, in this video we are going to have a look on this LeetCode problem 875, Koko eating banana. It's a very standard or frequently asked binary search algorithm based problem, and you can see it has been asked in a lot of good tier 1 companies in the last 3 months. First of all, let's have a look on the lengthy problem statement. The problem says that Koko loves to eat bananas, and there are n piles of banana where ith pile is going to have piles I values. That means this piles array are the piles of bananas, number of bananas in the ith pile. And the guards have gone and will come back in HRs. It is sure that within the HRs the guards will not come, and Koko can decide her banana per hour eating speed of K. So Koko has to decide a banana eating speed, which we are saying as K. K is the banana eating speed per hour. So every hour she will choose K bananas from a chosen pile. It means that every hour she will choose a pile, and from that pile she will eat at max K bananas. Let's say if K equal to 4 and she chooses first pile. So in the first pile there are 3 bananas. So she will eat all 3 bananas, and she will not eat any other banana in that particular hour. If the pile has less than K bananas, she eats all of them instead and will not eat any more banana during that hour. Okay. And there is another condition is that Koko likes to eat slowly. It means that there can be multiple values of K, but we have to choose the least possible value of K. It means she want to eat as slow as possible, but she has to finish all the bananas before the guard returns. So there is a specific condition that she can decide as low as the speed, but she has to finish all the bananas. And what we have to return from this function is minimum integer K. So that minimum possible value of K we have to return. Okay, so it's clear to us that we are having n piles. H is the maximum hours the guards will not come. So Koko is having plenty of time till H hours. She can choose her speed, banana eating speed accordingly. And in the constraints, if we have a look on the constraints, it is given that piles.length is less than equal to H. It means the number of hours are always going to be more than or equal to number of piles. It means there must be at least 1 hour per pile. That is, there is definitely an answer. We can have a particular any value of K. So let's say if we assume that, let's say K value of K is 100, it means Koko can eat 100 banana per hour. If Koko can eat 100 banana per hour, how many hours she will take to eat all the bananas? First of all, she will choose a pile. She chooses 0th pile and she eat all the bananas because her speed of eating banana per hour is 100. So she will eat 3 bananas in the first hour, and the first pile is empty. Okay, 1 hour is consumed. In the another hour she will eat 6 banana. In the third hour she will eat 7 banana. In the fourth hour she will eat 11 banana. So she took 4 hours to eat all the bananas. It means that value of K is fine with the second condition that we must finish all the bananas, but it is not keeping in mind that we have to keep the K minimized. So okay, I'm okay with that 100 is fine. So let's say if I choose 50, in case of 50 the answer also is going to be 4, and there is 8 hours total. It means she has 4 more hours. It means there is some scope of reducing the speed. If she will reduce the speed, she will take more hours to finish all the bananas, and there is already 4 more hours in the buffer, so she can reduce the speed further. If she take 10 as a K value of K, how many hours she will take? 1, 1, 1 and 2. 5 hours. and 5 are still less than 8. It means there's still some scope of eating bananas. So it is clear to us. And what is the minimum possible value? If I tell you that she will eat one banana per hour, she won't be able to finish all the bananas. So here what we are analyzing is that we can start from a bigger value, or you can say instead of 100, if I start with the maximum possible pile size from this array, will that work? Yeah. If I choose 11 as the banana eating speed per hour, so she will be able to eat all the piles in 1 hour. It shows that the maximum she can have is the maximum amount of banana in any pile. So let's say maximum in this case is 11. We want to reduce the value of k. So how can we reduce? We can reduce the value of k one by one. 11 we will check whether it's a valid value. Okay, capture it and try to explore further. We will check with 10. 10 is also valid. 9 is also valid. 8 is also valid. 7 is also valid. 6 is also valid. 5 is also valid. How it is valid? The bananas are 3, 6, 7 and 11. Ours are 8. So if I choose 5, 1 hour, 2 hour, 2 hour, 3 hour, 3, 4, 5, 6, 7. 7 total and maximum was 8. So 5 is also valid. What about 4? 1, 2, 2, 3, 7. 4 is also valid. If I take k as a banana eating speed per hour, so for 3, how many hours she will take? 1, 4, 4, 8 and 2, 10. So 10 is crossing 8. So this is not valid, and k and 4 was the least valid value. So as 4 was the least valid value, we are clear that these are all the valid values of k. And what is our answer? The minimum value of k is our answer, 4. In this case, what we did is we decided one by one from this 11 to 4. So this is going linear, but instead, as we can see, it is always decrement by by 1. Every time we are decrementing value by 1. So it is definitely sorted in the decreasing order. If it is sorted, why don't we just decide k using binary search algorithm? Okay. So if we go linearly, it will take order of n time. If we decided binary fashion, it will take order of log n to decide. Because if I choose 8 as the banana eating speed, there are two possibilities. First one is if it is valid. If it is valid, it means 8 is valid. Try to explore further on the lower side. If it is invalid, it means all of these are invalid. Keep exploring on the bigger side. So every time the answer space is reduced by half. So this is our deciding condition, our valid function. And what will be our valid function? Valid function we will implement as per the problem statement, that if she is able to eat or finish all the bananas, value of k is valid, otherwise it is not valid. So now it is clear with us that we are going to use binary search on the answer space, and answer is k is our answer, and answer can go from, if I just take the range, it will go from 1 to max. There is no other possible value, and the answer space is in the increasing order, and we can directly use binary search. So how do we write binary search? We decide two pointers, one is on the left side, one is on the right side, and we decide on our key. Usually we choose the middle element. If the middle element is valid, we will decide according to that whether which half we have to discard, which half we have to choose. Okay, now I have written a pseudo code here, but this is not complete. We will make the binary search algorithm from this range, and whenever the middle element is valid, if the middle element is valid, let's say middle element was 8 was valid, we have to capture 8 and we have to keep searching on the left part. Left part is the smaller values. So I will shift the right pointer So in this case, the right pointer will be equal to mid minus 1. And what if the 8 is not valid? If 8 is not valid, just keep exploring the bigger values. Why bigger values? It means the value of k is not sufficient to finish all the bananas. Value of k equal to 8 is not sufficient to finish all the bananas, so we will try to increase the value of k. To increase the value, we have to shift our left pointer. So left will be equal to mid plus 1. So this is going to be our binary search algorithm, and we have to decide on this valid function. This we can implement as per the problem statement. How we can implement? Mid value is the candidate of k. This mid value is the candidate of k, and we can see that if we choose this k value, whether we are able to finish all the bananas or not. And this is how our valid function will look like. Valid function is something that whether this chosen value of k is a valid banana eating speed or not. K will be the valid banana eating speed if Koko will be able to finish all the bananas with this speed. So how will she eat all the bananas? We will just capture the hours she will take if this is the speed. If these many hours are less than equal to h, it means it is a valid k. If she is taking more hours than the assigned one or the h1, it means the guard will return before she is able to finish all the bananas. So that is invalid. So how we can do that? The ith value of pile divided by k, and we have to take seal of it, because it can be something like we have to finish 7 where the value of k is 3. It means she will take 3 hours. In first hour she will eat 3 banana, second hour she will eat 3 banana, in third hour she will eat 1 banana. In total 3 hours. That is the seal of the value. And instead of taking a seal, what I do usually is current element plus this, the value we are using to divide this array. This is k minus 1 divided by k. K minus 1 is less than k, so it will not cause any trouble, and it will be the seal by default. The integer value it will return will be the seal, and this is up to you whether you want to implement it. So I plus k minus 1 divided by k, that will be added to hh, and hh will be compared later on. So this is the whole algorithm. Binary search on the answer space, and this is by valid function. And what is the time complexity in this case? What can be the maximum value of k? K will go till the maximum value of any pile size. So let's say that is n. So in this case it will be log n to decide the value of k, and n is to decide whether that value of k is valid or not. So time complexity is going to be n into log of n. And what is the space complexity? I don't think I am taking any extra space, so let's consider it -1. Okay, I hope you understood the approach. Now we'll code this problem. Let's capture the length of the piles. Piles.none. Now we'll have to decide our range. Int left is 0. 0 cannot be there. At least 1 will be the speed of Koko to eat banana. So 1 banana per hour. Let's consider left as 1. And what is the right? Right can be the maximum of these piles. But no, I don't want to iterate over it. I'll just capture the maximum possible value. That is 10 raised to the power 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this I have taken. So while the value of left is less than equal to right, I will capture mid value. Left plus right minus left divided by 2. Now I will see whether the mid is a valid value of k or not. If it is a valid value, just capture it and explore on the left side. right is equal to mid minus 1, else left equal to mid plus 1, and in the end I'm going to return answer. I'm taking answer as 1 in the starting. And now let's write our helper function, private boolean valid and integer k. I'm naming the variable as k because it is going to be the banana eating speed per hour. Okay, what is the actual number of hours given to us? That is h. H is also required, so let me also capture h here. Instead of that, I also require piles, integer array piles I'm also taking. So in the valid function I'm also taking h, total hours that we have, and the piles array. Int, let's say hh is the hours the Koko is going to take with this speed. If hh is greater than, it means valid, it will return true. Now I have to iterate over this array. Int p piles int hh plus equal to, not int, hh plus equal to p plus k minus 1 divided by k. This integer value is going to be the seal automatically, and in the end hh is less than equal to h, it is valid. If hh is crossing it, it is not valid. Let's run over sample test cases. This is h, not n. Running it over sample test cases. Okay, sample test cases are passed. I'm submitting the problem. It got failed. 125 cases are passed out of 136. Now this test case is failing and all the other test cases are passed. This might be because of the overflow. So what we will do is we'll add a negative case. In this case, what is the negative case? If hs is crossing h at any moment, we'll just directly return false. Otherwise, return true. There is no issue in the code. Okay. Running over the sample test cases again. This time this test case is also passed. I am submitting the problem. It got submitted successfully. Hope you understood the problem. Thank you guys. If you have any doubt, you can comment down below. Okay, bye bye.